Okay, guys, we are going to take a look at our last type of naming, which would be naming acids. And if you have looked at the PowerPoint, you've looked at the notes, and you see that the key element we are looking for in an acid is hydrogen. The presence of that hydrogen really denotes an acid to us. And we're going to be looking at two different types of acid. Okay, so the one thing that we could see is hydrogen plus a nonmetal. When we see hydrogen plus one nonmetal, what we're looking at is a binary acid. Okay, and an example of that would be HCl. We see the hydrogen, that's telling us it's an acid. We see the chlorine, chlorine's a nonmetal. So in this situation, you have hydrogen and a nonmetal. And we are going to identify this by first writing the prefix hydro. You look at the nonmetal, and you're going to go ahead and write chlor, and you're going to drop the INE and add IC to the end. So you've got that prefix hydro, that suffix ic, and you're going to end it with acid. And so here we see hydrochloric acid. Another example would be hydrogen and iodine chemically combined. Again, we see that hydrogen, we see that iodine, which is our nonmetal. And so once again, to name that, we're always going to write hydro as our prefix. We're going to write IO, drop the INE at the end of iodine and change it to ic. And you're going to end it with the word acid. Hydroiodic acid. Now, if we see something that has hydrogen in it, but we see multiple nonmetals like polyatomic ions, which we understand have oxygen in them, which is where that oxyacid comes from. So let's take a look here at a very common one. You've heard this before. Let's take a look at H2SO4. This is an acid because I see that hydrogen there, and I now see that SO4, which we know is the sulfate ion. So here we have hydrogen plus a polyatomic ion, and let me show you how we're going to go about naming this. No prefix hydro on these, okay? What you're going to do is if the polyatomic ion ends in ATE, you're going to change the ending to ic. So for example, that is sulfate. Notice how that sulfate ends in ATE, which means we're going to change that to ic. So the name would become sulfuric acid. Once again, you've got to add that acid word there so that people can know exactly what we're talking about. Now, what if we had an example where it was HClO2? We see that hydrogen, so we know it's an acid, and then there's a polyatomic ion, ClO2. If you look up your ClO2, you're going to see that that is chlorite, ITE, okay? If something ends in ITE, the ending is now going to change not to ic, but to OUS, okay? So in this situation, I'm going to drop the ITE, and I'm going to change that to chlorous acid. So again, whenever we're looking at naming these acids, the step one is when we see that hydrogen, we know that there's an acid there. And you've got two different sets of naming. You've got the binary acid, which is hydrogen and a nonmetal, or you have an oxyacid, which is hydrogen and a polyatomic ion. Each type of naming uses some different rules. So let's go ahead and take a look here at a couple of more examples. In this one, you're given the name hydrobromic acid, and maybe we're asked to write the chemical formula. So key thing here is that you see it's an acid. And excuse me for just a second. I am going to try to zoom in just a little bit here. There we go. It's a little bit better. We know it's an acid, which means it contains hydrogen, and all of these hydrogen is going to be that +1 on there. Notice that we see bromic, that hydrobromic, which means we're also dealing with the bromine anion, which has a -1 charge. So if I were trying to write the chemical formula, +1 and -1 cancel each other out, and I would be left with HBr, which is hydrobromic acid. Next one, we see that hydrogen, so we know that it is definitely an acid. And now you have to ask yourself, is it a binary acid or an oxyacid? We'll take a look here. You definitely have a polyatomic ion there. You have NO2. Take a moment right now and look up what NO2 represents. And you will see that NO2 represents nitrite. Notice that ITE there. ITE is going to change to OUS. And so the name of HNO2 would be nitrous. And then don't forget to add the word acid there. Next one, we see hydrogen. We know it's an acid. Then we see this SO3. Anytime you have that hydrogen and that polyatomic, the very first thing that you need to be doing is looking up what the name of the polyatomic ion is here. So here we have sulfite, which is going to end up being very similar to the one that we just looked at. That ITE is going to change over to OUS. And we end up with sulfurous acid. Okay, again, don't forget the word acid there at the end. And the last one we want to look at is hydrosulfuric acid. And again, this time we're writing out the chemical formula so we know it's an acid. We're going to go ahead and put that hydrogen with that +1 charge. Notice that this is not a polyatomic ion, and I know that because I see that prefix hydro, which means we're dealing with one nonmetal here, and I can see that it's sulfur. If you look up sulfur, sulfur has a -2 charge. And now this is just looking like an ionic. So we've got the -2 and the +1. How many hydrogens do I need to cancel out that -2? I need 2 hydrogens to cancel out that -2 on the sulfur. Okay, so a couple of examples there. Please do not overcomplicate these. Just make sure you're identifying whether or not it is a binary or an oxyacid on the front end, and that will help you out tremendously.